You're watching part 11 of our Industrial IoT mini-series of videos. We've talked about the main challenges customers are facing, how the Microsoft Azure services can address them, all the way from the edge to the cloud. And now we're talking about scaling, more particularly security, and how you can scale your IoT solutions, integrate into your IoT infrastructure in a secure way. Security is paramount to the scalability of industrial IoT. Having a single pane of glass to have an eagle view of what is happening at each factory allows operations, IT, and security teams to stay alert, anticipate the threats, and react quickly. It's about getting full visibility into assets and risk across IT and OT environments. Not that they are connected, it is more important to increase visibility over them. Continuously monitor for threats and vulnerabilities, because threats are evolving. It's about, achieving a protection of your brownfield and IT assets, reducing the attack surface and impact, and improve the operations uptime. Operations engineers, security architects, IT architects are the ones implementing the security features for securing IT and OT across your infrastructures. And the people taking advantage of that are operations manager. Now they can access data they couldn't before for security reason. Now they can in a secure way. IT analysts, cybersecurity analysts. Looking at the Parnell aerospace architecture, we'll be focusing on the security aspects of the infrastructure, the OT infrastructure connectivity to the cloud. We'll talk about Defender for IoT. We'll look at the support for private endpoint in a second. The standard IoT Central endpoints for device connectivity are accessible using public URLs. That means that any device with a valid identity can connect to your IoT Central application from any location. But you can use private endpoints to limit and secure device connectivity to your IoT Central application and only allow access through your private virtual network. Private endpoints use private IP addresses from a virtual network address space to connect your devices privately to your IoT Central application. Network traffic between devices on the virtual network and the IoT platform traverses the virtual network and a private link on the Microsoft backbone network, eliminating exposure on the public internet. Private endpoints in your IoT Central application will enable you to secure your cluster by configuring the firewall to block all the device connections on the public endpoint. Increase security for the virtual network by enabling you to block exfiltration of data from the virtual network and securely connect devices to IoT Central from on-premises network that connect to the virtual network by using a VPN gateway or express route private peering. On the egress side of things, when you configure a data export in your IoT Central application, to send your assets data to other Azure services, you can choose to configure the connection to the destination with a connection string or a managed identity. Managed identities are more secure because you don't store the credentials for your resource in a connection string in your IoT Central application. The credentials are automatically tied to the lifetime of your IoT Central application, and managed identities automatically rotates their security keys for you. Using managed identity to export data from IoT Central, you can further secure your OT and IT integration. While we're discussing network, I want to bring your attention to the way industrial networks are built. Most often, they are built in the form of layers, compatible with the Purdue model that if you are in the industry world, you are certainly familiar with. Because we meet our customers where they are, our edge technology is compatible with ISA 95 networks, allowing additional security through network isolation without compromising productivity and asset connectivity. Azure IoT Edge devices can be nested to securely collect data across networks organized in hierarchical layers. Industrial customers commonly use layer networks based on the Purdue model to isolate and secure their most critical assets. With this IoT Edge capability, customers can collect data from each layer and gain local insights to help reduce unplanned downtime, increase equipment efficiency, and reduce product defects while fully complying with strict industry standards and without compromising security. Note that the offline operation support of Azure IoT Edge works the same way when devices are nested. Devices will hold the data and transfer it when devices get connected. Last but not least, you can deploy and manage the same workloads on your edge devices, whether they are or not nested in a layered network, meaning you can bring your Vision AI and other models all the way down to your level 1 or 2 on your Purdue network. Adopting layered network models and controlling access to devices is only part of a good IoT security solution. Microsoft Defender for IoT allows to passively but closely monitor network activity. No agents to deploy on devices, no performance or reliability impact on the OT network, because Defender for IoT is only analyzing a copy of the network traffic obtained from the span port of a network switch with nothing placed in line. Defender for IoT is powered by specialized behavioral analytics with machine learning, which means there is no need to configure rules or signatures. Furthermore, Microsoft Defender for IoT has a deep integration with Azure Sentinel, meaning that it's easier and faster to investigate multi-stage attacks that often cross IT and OT boundaries. Let me show you a little sneak peek into Microsoft Defender for IoT. Once the Microsoft Defender for IoT sensor is connected to the span port of a network switch, it will start collecting data and send it to Microsoft Defender for IoT. Defender for IoT will then build a devices map that you can see here. I can now dig into devices details. On this one, I can see it's a PLC, it's from Rockwell Automation, we've got its IP address, MAC address, the protocol it's using. We also have information on the backplane. If I click on this device, I can see it's on rack 1, connected to the default slots, and I can see its model and serial number as well. All of this information was collected passively by just listening to the network. You can also see this blue line that shows these two devices are connected together, and I can inspect the traffic between the two devices. The connection map will also allow to understand the segmentation policy of my network. You can see that the map is split in several sections corresponding to the Purdue layers of my network. Microsoft Defender for IoT has a built-in threat intelligence that will scan the traffic to identify potential issues. Here we see alerts, and we picked up a port scan, which is traditionally associated with an attack. I can go into the port scan for details and decide if it's an actual issue or if I can teach Defender that this is an expected event and behavior. Likewise, because we have deep understanding of OT protocols thanks to our M2M analytics engine, we're able to detect specific elements in these protocols. Here I have seen an S7 stop PLC command that was sent from one device to another. This is telling me that I need to pay attention to it. I can then download packet captures to send to my security analyst team, or I can look into my event timeline to better understand what happened leading up to that alert. So here my alert is on top of the timeline, and I can scroll to track issues that preceded. This is just a small sample of all the functionalities offered by Microsoft Defender for IoT to secure your assets.